Hi, welcome back. In this video, we're going to talk about memory tuning again. If you recall, we talked about how we can use the Lumigo CLI and the AWS Lambda Power Tuning app to find the best memory setting for performance. But now, we're going to see how it applies to cost as well. And a quick refresher, Lambda charges you based on both invocations and their duration. But when it comes to provision concurrency, you have another uptime cost. On the flip side, you do have a lower duration cost per gigabyte second, which is something you can actually exploit, and we look at provision concurrency later in this chapter. A function that's just doing some I/O is probably not going to see much benefit from adding more memory, as the CPU is just going to sit idle. This type of functions are prime targets for reducing costs by reducing memory allocation all the way down, unless you're uploading or downloading a large amount of data and need all the bandwidth you can get, in which case you do need to have more memory, as bandwidth is also tied to memory allocation. But in my experience, the bandwidth I get for 128 meg is sufficient for most cases. Your DynamoDB calls are not going to be noticeably slower if you run on 128 meg because of bandwidth. A CPU-bound function will see significant performance improvements as you add memory. The danger of optimizing for cost here is that you're gonna get exactly what you ask for. The cheapest, but also worst performing configuration. While it might save you some Lambda cost, it can also give your users a bad enough experience that it can start to impact your sales or conversion rates, as Amazon and Google and many other companies have found. So when you're tuning your function configuration for cost, I would strongly recommend that you use the balanced profile and try to find a good balance between performance and cost. And that would be my first rule of thumb. Another thing to consider is that duration costs are charged in 100 millisecond blocks and always rounds up. So if we can make our functions go faster by giving it more memory, we might actually reduce the cost at the same time. Consider a function that performs a combination of I/O and CPU-bound operations like this. I've literally just combined the two earlier functions together. You might see something interesting here, where by increasing memory from 128 to 192 meg, we reduce the average execution time from 138 milliseconds to 99 milliseconds, just under the 100 milliseconds threshold. So we end up paying for 100 milliseconds of duration rather than 200 milliseconds, albeit at a higher memory setting. And the end result is that our function is actually cheaper and faster. And even if we go up to 256 meg, the cost will still be the same as 128 meg, but the performance has more than doubled, giving us a free upgrade essentially. So that's my second rule of thumb, to be on the lookout for this type of free upgrades. With the Lumigo CLI's PowerTune Lambda command, you can provide extra power settings, which is how I got 192 meg setting into the graph. And before we go crazy with these micro cost optimizations, I should remind you that for vast majority of the cases, these small cost optimizations are premature and will yield negligible savings at best. And as Don Lanu famously said, premature optimization is the root of all evil. But we should not pass up our opportunities in that critical 3%. And to help us identify that critical 3%, you should use tools that can give you visibility into the cost of your serverless application, not just Lambda functions. And that's what we're going to look at in the next lesson. I'll see you there.